Welcome back, I'm Chris Moore with HVAC Pro Blog, and this week I want to talk about the impact of ductwork on load calculations. Without further ado, here's the training. Alright, the most sizable change in ACCA Manual J when moving from version 7 to the most recent version 8 is in the inclusion of duct conditions and loads. Before including details like location, layout, surface area, like a radial versus trunk and branch, the insulation and leakage, Manual J version 7 just added an arbitrary percentage to the load that the designer would choose. Since the implementation of these new, more accurate calculations, the ACCA have moved duct systems into the spotlight. I feel this from a bit of enlightenment by the industry and code council committees. Be careful if you listen on, you cannot unring this bell. When choosing the infiltration for a home, it's no secret that HVAC contractors are not using a blower door and actually calculating the air changes per hour. For those that actually do, the leakage of the home or infiltration is probably the largest contributor to the heat loss, and they know this because they measured it. The equivalent to this for duct systems is measuring the leakage with a duct blaster. As you're going to see, the leakage of the duct system, like infiltration of the home, is the largest contributor to duct loads, no matter where the duct location is. If you're completing a load calculation, choosing the correct conditions is paramount into calculating the correct heat loss and heat gain. Since most people can easily identify the location, the layout, and R value, the unknown, unless you measure it, or even if you do, is what to select for leakage. Here's a great translation that's based on Table 7BT and ResNet. It's the testing completed CFM 25 per 100 square feet for an attic system. Table 7BT, it's listed on resnet.com. As you can see, an extreme system is 1.8%. Notable is 3.3%, and it goes up from there. Average is 4.7. Partially sealed is 9.4. Unsealed is 13.8%. Believe it or not, that's extremely conservative. If you're completing installations of a new duct system to meet today's code requirement, which is less than 4 CFM per 100 square feet in the IECC, then you should set your duct leakage to notable. Extreme leakage is typically achieved by systems like AeroSeal and stuff. Now let's take a look at how changing these settings impact the heat loss and heat gain for my own house in Central Mass. As you can see, it doesn't matter about the R value, the slight difference between R6 and R8. If it's in the attic, there is a difference on what you're setting for leakage. And the same applies to a basement. The biggest impact to the load is the leakage of the ductwork. Of course, if it's inside the building or you're installing a ductless system, there are no loads, right? Notice the significant reduction from partially sealed R6, which is your typical existing duct system, compared to replacing the duct system to meet the code of notably sealed in R8. Regardless of the location, we're talking between 15,000 to 18,000 BTUs in heat loss, 6 to 9K in heat gain. This will change the size of your AC or heat pump for sure in my house. Just to really drive home the point, when all of the ductwork is located in the building envelope, or you're installing ductless equipment, there's a 1 to 2.5 ton swing in heat loss or a 0.5 to 1.5 ton swing in heat gain. The moral of this story is if you're not measuring, then you're guessing. If you're not changing the defaults in software, not looking in the attic, or understand what the codes are, then you're most likely guessing incorrectly. If you're off a bit on duct insulation, or you say a duct system's average instead of partially sealed, you're not likely going to change the size of your equipment. But if you have no clue what you're doing and choose a drastically different option, let's just say you sized the system wrong. Thanks for joining me this week at HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis. I'll see you soon.